Let's practice multiplying fractions, whole numbers, and mixed numbers together. For each of these practice problems, I'm going to solve them two different ways. One way I will break the numbers down into their prime factorizations, then cross out common primes between the numerator and denominator. And the other way I'll use cross-canceling. So use whichever method makes more sense or is more helpful to you. Alright, so for number 1, we have the fraction 3/4 times 5/3. Now 3 is already a prime number, so that's going to stay the same. And 5 is a prime number, so that'll also stay the same. The 4 will break into 2 times 2, and the 3 is already a prime number, right? So this would be what this whole thing would look like together as one fraction bar with a bunch of multiplication going on here. And so what do they have in common? It looks like the top and the bottom both have a 3. And if you go ahead and cross those out, then the only number left on top is going to be 5. And on bottom, we have 2 times 2, which is going to be 4. So you could leave your final answer as 5/4, or as a mixed number, you could say that's going to be 1 1/4. All right, now if you were going to use cross-canceling, then you would go ahead and just take this original fraction of 3/4, and when you're multiplying it by this 5/3, you would just look to see if there's anything that's common on top and bottom. They don't have to be prime. So 3 and 3, they can cross-cancel to make 1 if you divide them both by 3. And so on top here, you're just left with 1 times 5, which is going to be 5. And on bottom, 4 times 1 is going to be 4. So you're going to get the same thing either way. And if you want to convert that to a mixed number, you can as well. Okay, so that's how you go ahead and use both methods here. Now, if you look at number 2, we have this 5/9 multiplied by 3/4. So if we go ahead and make one fraction bar here, now 5 is prime and 3 on top is also prime. Now the 9 on bottom will break into 3 times 3, and the 4 can break into 2 times 2. So what do they have in common? Well, looks like they have a 3 and a 3 on top and bottom. But I think that's it. So on top, we're just left with a 5. And on bottom, we have 3 times 2 times 2. 3 times 2 is 6, 6 times 2 is 12. So our product here, or the answer to a multiplication problem, would be 5/12. Okay. Now, if you wanted to use cross-canceling, feel free to do so as well. So you have 5/9 multiplied by 3/4. And so looking for something that top and bottom have in common, this 3 and 9 both have a 3 in common. So 3 divided by 3 is 1. 9 divided by 3 is 3. I think that's it. So on top, 5 times 1 is 5, and on bottom, 3 times 4 is 12. So we do get 5/12 using cross-canceling technique as well. All right, moving on to number 3. For number 3, it looks like we have 9/10 multiplied by 5/6. So we can go ahead and break that 9 down. 9 can break into 3 times 3, and that 5 is just going to stay as 5. 10 on bottom breaks into 2 times 5, and the 6 will break into 2 times 3. Now, what do they have in common? Looks like they both have a 5. Get those out. And then they both have a 3, so you can cross those out. The only thing left on top is a 3. And on bottom, we have a 2 times 2, which is 4. So the product here would be 3/4. Now, if you wanted to use cross-canceling, you could take this 9/10 and multiply that by the 5/6 and look to see if they have any common factors. Now, it looks like to me that 5 and 10 can both divide by 5. So 5 divided by 5 is 1. 10 divided by 5 is 2. And then you can also notice here maybe that the 9 and 6, you can divide them both by 3. So 9 divided by 3 is 3, and 6 divided by 3 is 2. Now on top, 3 times 1 is going to be 3. And on bottom, 2 times 2 is 4. So we get 3/4 using this other method as well. Moving on to number 4. For this one, looks like we have a whole number. Okay, interesting. So 12 is going to be the same thing as 12/1. So I'm going to rewrite this as 12/1 multiplied by this 5/9. All right, so that's going to be something we want to do first to make sure we have numerators and denominators. Now, what does 12 break into? 12's prime factorization is 2 times 2 times 3. 5's prime factorization is just 5. On the bottom, we have a 1, which we don't really need to write, but I'll write it anyway. And then 9 breaks into 3 times 3. Now, looking for some common primes, it looks like they both have a 3, and I think that's it. And then on top, we're left with a 2 and a 2 and a 5. So 2 times 2 is 4. 4 times 5 is 20. And on bottom, 1 times 3 is going to be 3. So this could be one way to write your answer, this 20/3. Now, if you want to write it as a mixed number, 3 fits into 26 times with 2 left over. So we can also write 6 2/3. So this is another way to write your answer. Okay. Now, if you want to use cross-canceling, that's fine. You can write this 12/1 multiplied by 5 over 9. And it looks like 9 and 12 are both divisible by 3, so 12 divided by 3 is 4, 9 divided by 3 is 3. Then on top here, 4 times 5 is going to be 20, and on bottom 1 times 3 is 3. So that's the improper fraction version, and you can convert it to a mixed number if you would like to. For number 5, we have 1/6 multiplied by 8, so 1/6 stays the same, but 8 as a fraction would be 8 over 1, right? Now if you want to go ahead and write the prime factorizations broken down, 1's going to stay as 1, but 8's going to break into 2 times 2 times 2, and the 6 on bottom will break into 2 times 3, and then we still have a 1, okay? So if we go ahead and cross out something in common, they both have 2's. I guess you can cross out the 1's if you want, doesn't really matter. And on top, 2 times 2 is going to be 4. And then on bottom, 3 is just 3. So this would be the improper fraction version. And if you want to turn it into a mixed number, that would be 1 and 1/3. So either one of those answers would be fine. Now if you wanted to practice cross-canceling or just give it a go, we have 1/6 times 8 over 1. And something that 8 and 6 have in common is 2, so if you divide these both by 2, we get 3 on bottom and 4 on top. And then 1 times 4 on top is 4, 3 times 1 on bottom is 3, so we do get this 4/3, which is what we got earlier. For number 6, we have a whole number of 18, and so 18 as a fraction is 18 over 1, and we're going to multiply this by 11/12, so it's going to be 11 over 12. Now if we go ahead and write prime factorizations, we can go ahead and do so and say, okay, 18 is the same thing as 2 times 3 times 3. Okay, we also have a times 11 on top, right? And on bottom we have 1 times, and then 12 breaks into 2 times 2 times 3. Now what do they have in common? Looks like they both have a 2, we can cross those out, and they both have a 3, so we can cross those out. And so on top we have 3 times 11, that's going to be 33. And on bottom we have 1 times 2, which is going to be 2. So as an improper fraction, this would be our product. But if you want to write this as a mixed number, 2 fits into 33 16 times. So that's going to be 16.5. And if you want to use long division to check that, feel free to do so. But hopefully that should check out for you. Okay. If you want to use cross-canceling, this would be 18 over 1 multiplied by 11 over 12. And I think everything's relatively prime except for the 18 and 12. Their GCF is 6. So if you divide these both by 6, you're going to get 3 and 2. I think that's it. Everything else is relatively prime. So on top, 3 times 11 is 33. And on bottom, 1 times 2 is 2. So we do get the 33 over 2, which gets you the same mixed number as 16.5 if you wanted to do that. All right, for number 7, we have a mixed number and an improper fraction. Okay, so if we deal with this, we have to multiply 3 times 3 is 9. 9 plus 2 is going to be 11. So this is the same thing as 11 over 3 multiplied by 6 over 5. Let's go ahead and write this using prime factorization. So 11 is already prime, and then 6 is 2 times 3. And on bottom, 3 times 5, these are both prime numbers, so they're going to stay. The 3 and the 3 can cross cancel here, or we can cancel those out. And then I think on top we just have 11 times 2, which is 22. So we can write 22 fifths as our improper fraction version for the answer. Or you can turn it into a mixed number. 5 goes into 22 4 times with 2 left over, so 4 and 2 fifths. All right, so these both of these answers would be valid. Okay. Now, if you wanted to use cross-canceling, I'm going to go ahead and just use the improper fraction version of 3 and 2/3 and multiply that by 6 fifths. So you still have to use those. The 3 and the 6 can both divide by 3, so it'll be 1 and 2. So on top we get 11 times 2, which would be 22. And on bottom, 1 times 5 would be 5. So that gets us the same thing we got earlier. Now if we move on to number 8, we have a whole number of 8. So let's go ahead and take that and write 8 over 1 multiplied by, and we have to convert this 3 and 1/6. So 3 times 6 is 18 plus 1, that would be 19. So we're going to go ahead and write 19/6 for the equivalent to 3 and 1/6. All right, so using prime factorizations here, 8 is the same thing as 2 times 2 times 2. 19's prime, it stays the same. 1 stays the same, and then 6 breaks into 2 times 3. So you notice that the only thing they have in common is a 2 here, so you can cross those out. so not a whole lot of canceling out going on here. And on top here, we have 2 times 2, which is 4. 4 times 19, you can check that, but that should be 76. And then on bottom, 1 times 3 will be 3. So this would be the improper fraction version. And if you're doing the mixed fraction or mixed number version, then I think 3 goes into that 25 times. That's going to be 75, and then plus you have an extra third. So 75 plus 1 is 76, so this is going to be 25 and 1/3. Now, if you couldn't do that in your head, then you should be writing out some long division to check that and to make sure it makes sense. Okay, using the shortcut here of using cross canceling, I guess it's not really a shortcut, but a different strategy. You can have 8 over 1 times 19 over 6, and 8 and 6 you can divide them both by 2, so you can get 4 and 3, and then on top 4 times 19 is that 76, and on bottom 1 times 3 is 3, so we get the same thing either way. For number 9, we have 4 and 3/4. Let's turn that into an improper fraction. So 4 times 4 would be 16, plus 3 would be 19. So we should have 19 over 4 multiplied by 6. 6 as a fraction is 6 over 1, right? Now if we go ahead and write this out using prime factorizations, we have 19 here, and then 6, it's going to be 2 times 3. And on bottom 4 is just 2 times 2, and then we have a 1 here, right? Now we can cancel out a 2 and a 2 on top and bottom, but I think that's it. And then on top, 19 times 3 is 57. On bottom, 2 times 1 is 2. So this would be the improper fraction version. And if you want to turn this into a mixed number, I think this is going to be 28. 2 times 28 is 56 and a half. All right, cool. So these would be our 2 different versions of the same answer. And if you wanted to try cross canceling this 19 over 4 times 6 over 1, it's definitely less writing. You can divide these both by 2, that's their GCF, so you get 2 and 3. And on top, 19 times 3 is 57, and on bottom, 1 times 2 is 2. And so that matches what we just did a moment ago. Let's check out number 10. For number 10, we have a mixed number times a proper fraction. So let's take this 4 and 2/5 and make it improper. So 4 times 5 is 20. 20 plus the 2 on top, that's going to be 22. So we have 22 over 5, and we're going to multiply that by 10 over 11. All right, so let's go ahead and write the prime factorizations here. So 22 is 2 times 11, number 11's prime, and then 10 will break into 2 times 5. Now 5 is prime, so we're going to keep that, and 11's prime, so we're going to keep that. Looks like we can cross cancel these 11's, which is great, and these 5's, which is also great. So actually nothing's left on bottom, which is kind of nice because that means the denominator is 1, so we have no fraction for an answer. And then on top, 2 times 2 is going to be 4. So we would leave our final answer as just 4. You wouldn't write 4 over 1. Okay, so let's go ahead and check this out using cross canceling. So if we have 22 over 5 and we want to multiply that by 10 over 11, let's see what happens here. We can see that 22 and 11, they can both divide by 11, so we get 2 and we get 1. And then 5 and 10, you can divide both by 5, so you get 1 and 2. So on top here, 2 times 2 is 4. On bottom, 1 times 1 is 1, so 4 over 1 is just 4. So this matches, so we should feel pretty good about that. Number 11, we have a mixed number and another mixed number, so let's convert those first. So 2 times 12 is 24. 24 plus the 11 on top is going to be 35. So we're going to get 35 over 12 for our first mixed number written as an improper fraction. And then for the second one, we have 2 times 7 is 14. 14 plus the 4 on top is going to be 18. So that's going to be 18 over 7. All right, so we don't really want to multiply these out. We want to try to use maybe our prime factorizations here. 35 breaks into 5 times 7, and then 18 breaks into 2 times 3 times 3. The 12 on bottom will break into 2 times 2 times 3, and the 7 is already prime, so that's going to stay as a 7. Let's see if we can cross cancel. Looks like the 7 and 7 are in common, and the 2 and the 2 are in common, and the 3 and the 3 are in common. I think that's it. On top, 5 times 3 is 15. On bottom, 2 is just 2. So this would be our answer, our product written as an improper fraction. but you can also turn this into 7.5 if you would like to. All right, so there's our products. If you want to try cross-canceling, let's do 35 over 12, and let's multiply that by 18 over 7. I think we can cross-cancel the 7 and 35. Divide them both by 7, we get 1 and 5. And then for the 12 and 18, you can divide them both by 6. That would be their GCF, so you get 2, and then you would get 3. And then so if you go ahead and multiply on top, this 5 times 3, that's going to be 15. And on bottom, 2 times 1 is going to be 2. So we get the same thing, so this must have worked for us. For number 12, we have another couple set of mixed numbers here, last problem. So let's see here. 1 times 32 is just 32. 32 plus the 13 should be 45. So I'm thinking this first one is 45 over 32. That's that version. And for the second fraction, let's go ahead and see. 1 times 63 is 63. Plus 1 on top is going to be 64. So that's going to be 64 on top over 63 on bottom. Okay, so I think I'm going to run out of room if I go next to it, so I'm going to write the prime factorizations here. I think there's going to be a lot of fun stuff that will happen here. So let's see here. 45 is just going to be 3 times 3 times 5, right? And 64 I know is 1, 2, 3, 4, 5, 6. So it's 6 2's multiplied together. 32 is 1, 2, 3, 4, 5 2's multiplied together. And 63 is going to be 3 times 3 times 7. So these would be the prime factorizations written all as one big fraction, okay? So it looks like we have a 3 on top and a 3 on bottom, another 3 on top, another 3 on bottom. Looks like we have a 2 and a 2, another pair of 2's, another pair of 2's, another pair of 2's, and another pair of 2's. And I think that's everything. So we're left with a 5 and a 2 on top, so 5 times 2 is 10, and on bottom we have 7. So that would be our answer written as an improper fraction. And as a mixed number, you can say it's going to be 1 and 3/7. So hopefully you notice that that beats multiplying 45 times 64 and then 32 times 63 and then trying to simplify it down. It's much faster to use prime factorizations because then you don't have to simplify later. Now if you're using the cross-canceling method, we have 45 over 32 and we're multiplying that by 64 over 63. Then this might go even faster for you if you like this method. Now you might notice that 32 times 2 is exactly 64, so you can divide them by the GCF of 32. And then if you look at 45 and 63, they're both divisible by 9. So 45 divided by 9 is going to be 5, and 63 divided by 9 is going to be 7. So much faster, but 5 times 2 is 10 on top, and then 1 times 7 is 7 on bottom. And this looks like it was what it was supposed to be. So there you have 12 different practice problems. I did them all 2 different ways. Make sure you turn all the whole numbers into improper fractions by putting them over 1. You also turn all mixed numbers into improper fractions. And then if you're using prime factorizations, just break them down, then cross out those common primes. And if you're using cross-canceling, just look for GCFs and cross them out when you divide each numbers by their GCF. So I hope you found this video helpful. If you did, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.